So I want to do a couple more problems from 10.2, which is showing if a point is on a circle or not. These problems are kind of nitpicky because you can see like in the first problem, it's obviously multiple choice and you have to show the initial setup on the equation. However, this is not the only correct way to set up the equation and get to the right final answer. So I just want to make sure you guys have like a solid example of how to make your equations look like theirs, or if they don't, how to make sure that they're kind of like reorganized so that they do. Okay, so what makes these like a little bit weird is standard form of a circle is x minus h squared plus y minus k squared equals r squared. So in that formula, the center of the circle is h and k, and those are like the second term in each parentheses. However, the way that the workbooks and the exam order their equations is with h and k coming first in each parentheses, which the order really doesn't matter. Like x minus h squared is going to have the same outcome as h minus x squared. So for example, like if I did 3 minus 1 squared, 3 minus 1 is 2 squared, and then 2 squared is 4. Versus if I switch the order, negative 1, or sorry, not negative 1, it'd be 1 minus 3, because they're both positive. 1 minus 3 squared, and then 1 minus 3 is negative 2 squared, and then negative 2 squared is positive 4. So when you're subtracting something, or like finding a difference and squaring it, the final outcome is the same regardless of which way you order the numbers. So it really doesn't matter. It just matters here because you're asked which equation is like the correct setup. So you want your order to match theirs, or at least how to be able to like identify it even if you don't initially set it up in the same exact order. Okay, so for number 1, circle C lies on the coordinate plane with its center at 2, negative 2. Point A is on the circle, it's at negative 2, negative 2, and point P has the coordinates at 6, negative 2, and we want to see if point P is on circle C. So the center has to go in for H and for K. So H is going to be negative 2, or sorry, just regular 2, positive 2, and then K is going to be negative 2. So for the H's, we're going to put 2's in for both of those. So I'm just going to start by writing it above on each. And then for the K's, we're going to put negative 2 in for both of those. And then point A lies on the circle at negative 2, negative 2. I'm going to use like x1 and y1 for those. So I'll put like negative 2 will go in for x1 and negative 2 will go in for y1. So for x1, it's going to be negative 2. Remember that there's like a double negative there, so be careful with that. And then y1 is going to be negative 2 as well. And then the extra point I'm going to put in for the point that I'm like checking, I'm going to put in for x2, y2. So that's the 6, negative 2. So x2, y2. So I'll put 6 in for x2 and negative 2 in for y2. Okay, so I'm just going to go ahead and like put each value in now. So it'll be 2 and then minus negative 2 squared. But we would never just like leave a double negative like that. We would simplify it to plus. And then plus negative 2 minus negative 2 squared. So again, a double negative. So we're going to take out that double negative and put a plus there. Equals 2 minus 6 squared. And then plus negative 2 minus negative 2 squared. So change the double negative to a plus, and then now we have like our initial setup. So this is where we'd kind of want to look through responses and see if we have something that's there. So they both start with, or not both, but the equation starts with 2 plus 2 squared. So that eliminates my first and my last option, assuming like my equation is perfectly correct at this point. So it's 2 plus 2 squared, negative 2 plus 2 squared, so 2 plus 2 squared, negative 2 plus 2 squared, same thing here. The second part of the equation is 2 minus 6 squared and negative 2 plus 2, and both of these equations have that. So that means that we've narrowed our options down into like that second and third choice. So we have our equation. We got it in the right order because we got something that matches up exactly with what's there. If I had kept it in kind of like the standard form order, it would not look like those equations. So that's why you have to be careful and kind of pay attention to like what they're putting where. And this one's especially hard because there's so many of the same numbers, like a lot of the points involve 2's. Okay, so now to decide between these two answers, I just have to actually finish simplifying and see if I end up with the same number on each side of the equal sign. So 2 plus 2 squared would be 4 squared, and then plus -2 plus 2 squared, that would be 0 squared. And then 2 minus 6, that's -4 squared, plus -2 plus 2 is 0 squared. So 0 squared, those are just zeros that'll make a difference, so I just need to square the 4 and the -4. So 4 squared is 16. -4 squared is also 16. So since we got the same number on each side, it made the equation true. So that means that that point P, is on circle C. So notice like the only two differences between these two is like one says they're not equal and one says they are equal. And we got like two equal numbers, 16 equals 16. So we would choose the one that says that they are equal, and that point P is on circle C. Okay, so for 3, circle O is centered, and I just skipped 2. It's really similar to number 1. It just like ends up being not a true statement, so when both sides didn't equal each other. But number 3, circle O is centered at 5, -15, and point A, which is at 2, -14 lies on circle O. Which answer verifies that point P, which is 6, -12, is on that circle? So I'm gonna kind of maybe just rewrite that long formula so we have it here. So it was h minus x1 squared, and then plus k minus y1 squared equals h minus x2 squared, and then plus k minus y2 squared. So in the like previous problem, we used like the point that we knew was on the circle as our x1, y1, and we used the point that like we were checking as our x2, y2, and it doesn't always have to be like that. So it could be the other way around. So I would recommend like before you really get started on the problem, see what they're doing. Like see what numbers are going where. So like we know for sure like the center should be h and k. So like h would be 5, and then k would be -15. So like 5 and -15, those should be the first number in each parentheses. 5 for like the h's, and then -15 for the k's. But then for what they're filling in the rest, as far as like if whether or not A is going to be like your x1, y1, or P is going to be your x2, y2, or vice versa, like that can change. They can switch for sure. So in order to determine those, like we've already said that like 5 and -15, those are going to be the first numbers in each parentheses. For the other ones, we just kind of want to see like which numbers are they putting on each side of the equal sign. I know that makes no sense, but I just wish that they were a little bit more consistent with this. But they're trying to make it confusing so that like you understand it better, but it doesn't make it any less frustrating. Okay, so what I'm getting at is if you look at point A, it's 2, -14. There's no 14s on this side at all. There are some 14s on this side. So they must be putting in like 2 and 14 as their x2, y2, or just in general, like they're putting it on that side of the equal sign. And then like for the 6, -12, there's no 6's or 12's over here. They're all over here. So they must be putting that point P into like the left side of the equation. So that's something that's a little bit easier to adjust later on, just switching the sides of the equal sign as compared to like switching h and k. That's kind of a pain. But just keep in mind that you can save yourself like a little bit of a headache just by looking at that part first. So that means that I'm going to put my like point P is going to go into the left side of the equal sign, and then my point A is going to go into the right side of the equal sign. So h is 5, so it'll be 5, and then minus the x from point P, so 6 squared, and then k is negative 15, minus the y from point P, so minus negative 12, but we're going to change that to a plus 12, so it's a double negative, squared equals h, so 5, minus the x from point A, so 2, and then plus k, so negative 15, and then minus the y from point A, which was negative 14, squared, and then same thing, we have a double negative, so we're going to turn that into a plus. So now that we kind of did like the pre-work of like checking to make sure that our answer will align with theirs, it should, like, our exact answer should be here. So 5 minus 6 squared plus negative 15 plus 12 squared equals 5 minus 2 squared plus negative 15 plus 14 squared should be the second option. Okay, if we didn't do that kind of pre-work, it wouldn't be that big of a deal because like it would just end up being like this on the left side, and we could just kind of switch that. I will say though, like, just for making your life easier, even though they kind of order it differently than like the standard form of a circle, for problems like this, just go ahead and put the like center of the circle, h and k, as the first one in each of your parentheses. So just kind of use this formula right here. Okay, I'm going to erase that, zoom in, just in case you need to pause it and copy it down. But this is for all the problems that require you to determine if a point is on a circle or not.